Good afternoon, everyone, and welcome to today's lecture of your 1 month online course on deep learning. So, Padmavati ma'am will take your today's session. I'm giving you the rights, ma'am, so that you can start with the session. And if you have any doubts in the previous lecture, you can have a discussion with ma'am also. I'm
Thank you,
giving you
sir.
the rights, ma'am.
Yes, thank you so much.
Yeah.
Good afternoon, everyone. Am I clear? My voice is audible?
Yes, ma'am.
Yes, ma'am,
Okay.
audible.
Yes, ma'am.
Okay. And I hope I have shared my screen. I hope it is visible too.
Ma'am, screen is visible.
Okay. Okay. Thank you. Good afternoon, everyone. Let us start the second session. Today, I will be taking you with the terminologies of deep learning. Mainly, we do use a few of the terminologies, right? So we will go through each terms, and mostly we will cover all. And few of them I may not be covering today in today's session. Maybe in upcoming session, wherever we require, I will make you to go through it. Okay. So let's start the session. Here we do have a model, and for the model, what we are doing is how do we train the model? Okay. For training the model, we always say that I am giving, we do provide the input. Okay. Input is in the form of X comma Y. You can see here the screen. Input is in terms of X comma Y. Here X is actual input that we want to provide to the model. Okay. Whereas Y is my ground truth. For example, in the previous example, I have given image classification example, right, in previous session. So in that image classification example, we have very much seen that whenever I provide image of a girl, then it should provide the label as, my model should predict the label as girl, right? So when we say it should predict after training, okay, once we do train the model, okay, after training process is over, we can always say that yes, evaluation part will start. Okay, testing part will start. Fine. So whatever I have explained in the previous session was with respect to evaluation. Correct. After creating or after training the model, what if I give for the image class, if suppose I have built the image classification model, and what if I provide the test example? So whenever I provide the test example, it should give the outcome in terms of label, right? Because I have done the image classification. So in that case, suppose if I am providing, I am feeding the input image as girl's image, then it should provide, yes, girl is standing, girl is sitting, that kind of thing can be generated. Okay. Or simple classification, yes, it should provide the label as girl. Similarly, boys data, if I provide, then it should generate the image label as boy. Fine. So when I say that my model is generating the correct result, or okay, or how do I test the model? I do test the model by providing some test data. Correct. So I do provide the test data just to verify whether my model is giving correct result or not. It is same as we do write a program, and we do run the program, and we do test whether my program is working correctly or not by giving some input data, right? Suppose I have created the program in C programming language or in Python or in any other programming language. I've created a program to compute the sum of two numbers. Then how do I say that my program is working correctly? Once we do give input to the data, okay, 2, 3, then it should give me 5. Then only I say that yes, my program is working correctly. In a similar way, once my model is ready, once my model is trained, then I can feed the input data. Probably that input data is new to the model. That means my model has not seen that image previously. Okay, so whenever I feed the new data, then my model should predict the correct result. Fine. So that is nothing but testing process. Fine. And evaluating the model, right? So before evaluating the model, we need to do something. What kind of input I need to provide? To train the model, I need to provide the data in terms of x comma y. That means this capital X is indicating I do have n number of inputs. Okay, small xi always indicate, okay, at least in these deep learning session, we do try to understand what we mean by these capital term x, y and y hat. Fine. And in subsequent lectures, I will be using same notations. So all of you need to be aware of these notations. Okay, capital X is here is indicating my input. Fine. And in that X, I can have n number of inputs. That means n number of samples I can provide. Okay. Let's take the same example. I want to classify the image into two classes, images into two classes. For that sake, I have taken 10 images, 5 comprising of girl image and 5 comprising of boy image. So in that case, what I will be doing is I will be using, so in that case, I do say number of samples here are 10 to train the model. Okay. So number of sample of X are 10. Similarly, number of ground truth here is that I am classifying I myself know the actual output of those classes of those images. So what I will do is I will label each one of X corresponding Y, I. Okay, small capital Xi. Suppose first image belongs to a girl image. So that X1 will be my input data, whereas corresponding Y1 will be girl. Similarly, X2 belongs to boy's image. So X2 is that boy's image. Whatever JPEG image that I am going to feed in, that particular image will comprises of X2, and corresponding Y2 will be my label. That Y2 I myself providing the ground truth. Correct. Like this, I can have n number of Xi, small letter Xi's, and n number of small letter Yi's. Fine. So this is nothing but my input data. So I do provide input to my model, and what my model should do. My model should learn the input, okay, the X, I's in such a way that it should provide some predicted result. That predicted result I always notate with a key with a notation as Y hat. Okay. So how this particular model is being, or how the outcome is generated. The outcome is generated by the model with this particular functionality. Fine. So y hat, what we do is we do compute the y hat, or the model will compute the y hat based on some function. This function, actual function is not known to me. Actual function is not known to may be possible that it is not known to anyone. But what we need to do is we need to cross check, or we need to come up with some function. That function is representing, or it is equivalent to actual function. Okay, then only this I will be getting, or it will be generating the result as y hat. Fine. So this y hat is equals to some function, and this function takes the input. You can see this particular function takes the input as x. Okay, so by this term it must be clear to you that to train the model I need some sample set x1 y1 x2 y2 x and yn. So in short, I do call those xi comma yi as x comma y, capital X comma y. And what my model will do is my model will apply or use those data items, data samples to generate some outcome, that is y hat. Okay, so let us move, let us take some example to understand x, y and y hat. Fine. So here someone has is speaking. Okay, so what I will do is I will fetch the signal. Okay, I will extract the signal of the of whoever is speaking. I will extract that particular signal, and that particular signal will act as input to my model. Okay, so what I'm doing here is I'm generating a system, okay, speech recognition system, where based on my speech, okay, based on whatever speech that we are generating, it should, my model should generate corresponding, yes, it should generate the corresponding notations. Okay, so it should generate the transcript that a particular person, if I am speaking, then whatever I am speaking, that transcript should be generated. You all are aware of this example, uh, right? So you all watch videos, you all watch listen to music. Okay, so you all are familiar with these kind of annotations, or you can say you these kind of transcripts that keeps on generating, right? So this particular example itself, I can say it is an example of deep learning. It belongs to an example of deep learning, right? So like this, whatever a particular person is speaking, corresponding what we are generating some sort of notations, right? Transcripts. Fine. And now let us try to understand, this is my input. Okay, and why, what is why here is I have simply captured the signal by speaking how are you. Okay, this is exact representation when I speak how are you. Then whenever I do give my input to the model, now my model, if it is predicting, that is if it is giving the outcome as y hat as how are you, then I can say that because my model has captured, or it is able to represent whatever hidden inside this particular speech. Okay, so how do I validate this? I can validate whatever result outcome of this how are you, I can validate with this corresponding y. Okay, so this sort of generating this sort of deep learning algorithms, we do say them as in supervised learning algorithms. Fine. Why supervised? Because I know the data items and corresponding y also I know, right? So with each data item, I do have ground truth of that particular data item. I'm saying that this particular model is giving us the correct result. Okay, with good accuracy. So how do I say? Because what I'm cross checking my model's result, okay, that is output of the model, that is how are you, with my existing ground truth. If it is same, then I can say my model is giving good results, right? Let us move ahead. Okay. Now, let us try to understand the some term that is learning. Fine. We do say that we do make our model to learn the representation which exists in the inside the data. Okay. So in short, deep learning is a mathematical framework for learning representations from the data. So what we mean by that? Let us take an example. I am feeding the data to my while training the model. I do feed the data and it gives me some output. Let us say y hat. Okay, and afterwards what I do is I do check the solution, that is y hat, with my actual outcome or actual output, because I do have in my data only, I do have x corresponding label y. Okay, so I will use that existing label y, okay, corresponding label y, with the predicted y hat. Okay, I do check like this. Suppose if my predicted outcome is same as my outcome, actual outcome. We do say this as an actual outcome and this y hat as a predicted outcome, as I have shown in the previous slide as well, right? So if my y hat is same as y, then I say my training process is over, right? Or else there are only two possibilities. Either my training will complete or my training will be in process. Okay, when I say my training is complete, whenever I am getting the predicted outcome same as my desired one. Okay, or else now my predicted outcome is same as my ground truth. Then I say my training is over. Okay, this is the first option. The second option is whenever this predicted outcome is far off from with the actual y. Okay, so in that case I do say that whatever result that my model has generated is not close to my actual output, actual output of the data. Fine. So in that case, what I need to do is I need to retrain the model with the same example so that it should learn the hidden representation, so as to, again I need to retrain the model so as to bring this y hat equal to or closer to y. Okay, this process we do say it as a learning process, and this learning process we do repeat this particular cycle till this y hat is equals to y. Let us take an example. Now this is the handwritten 3, the same example that I have taken in the previous session. The MNIST data set has handwritten digits from 0 to 9. Okay, so in the training folder, we do have 60,000 images. So this image I have taken from the same source, right? So you all can see it clearly that the person, whoever has written, he has written digit 3. Okay, so that digit 3 is my x and this is my corresponding y. I know that there are 10 digits that exist in the example, but for with this particular corresponding xi, let us take, this is the first example, so let me take this example as x1. This x1 is representing this particular y1. Okay, so let us try to understand. 3 is my input image and corresponding vector, okay, corresponding index, you can say corresponding index is 1 and rest of the indices are 0. That means 0, 1, 2, 3. Because this is 3 and my corresponding index inside my ground truth should be 1 and rest all will be 0. Okay, suppose x2. let us take the second sample. If I take the second sample and that second sample indicating digit 0. So corresponding, how do I generate corresponding Y? Corresponding Y can be generated with you need to make the index digit index 0 index 0 as 1 and rest all digits will indicate as 0. Correct? Now what we need to do is, because let us take the first example only, x1 3 and corresponding index, that is at the third place I need to make it as 1 and rest all are 0. This is my ground truth y1. Okay, so this x I will feed to my training to train the model, and later on I will get some output. Okay, I will get the output and the output indicates some again y hat. My y hat is representing again some values. Okay, based on whatever my model has trained. Okay, till now we have not seen how to train the model. Leave it, we will see in subsequent classes. But suppose think that my model has trained on some digits, 0 to 9 digits, it is able to produce some result, but the result are not accurate result. The results are erroneous result. Okay, how do I say it is an erroneous result? By checking the y hat. Y hat here is 0. This is indicating 0th digit, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on, right? So here you can say y hat of 2 is coming out to be 0.2, whereas y hat of 3, it is coming to be 0.8. Correct? But actually we could have received, if my model has trained it correctly, okay, completely, then it could have given the result something like this: 0, 0, 0, 1 and rest all are 0. That means my y hat will be, could have been same as my y, but still there exists some error. For that sake only this y of 2 is 0, whereas y hat of 2 is 0.2. My model has learned the training images. Okay, based on the training images, it is able to give, it is able to predict with the probabilities that the given input image, it looks for my model, for me it is 3, but for my model it is giving the output as 0.2. With a 20% of probability, it is saying that this digit will be 2, whereas with 0.8, that is 80% of probability, it is saying that the given digit is 3. So what I need to do is, once we get the y hat, again I will check the solution, that is the solution that I obtained with a model, that is y hat with the y. Here there is a huge difference, right? It could have been 1 and it could have been 0. Then I could have said that my model has predicted correctly, but here my model has not predicted it correctly. When I can say that? Whenever I check my y hat with y. Okay, so after checking y hat with y, I again make my model to
Hello,
yes.
ma'am, your voice is not audible.
Sakshi, is there any issue at my end?
No, ma'am. Your voice is audible.
Are you sure?
Yes, ma'am. Your voice is clear.
Okay, okay. Thank you. So let me continue. Now, once we say that, let's continue this. So whenever I get the erroneous result, that means my y hat, the computed y hat is very far off from my actual y, then again I need to retrain the model. Okay. Someone unmute and let me know, do I need to retrain the model again?
No, ma'am.
No.
Ma'am.
Why?
Because y hat is equal to y.
Yes. Because yes, please mute yourself, because my actual output, that is sorry, my predicted output is same as my actual output. For that sake, I say that my model has trained completely on the input images, that is training images. So in deep learning, we do have the layered representations are learned via model. Basically, we call them as a neural networks. Fine. So we do say as a neural networks, which is nothing but a structured layers which are stacked on one on top of the other. Okay. I do say we do have n number of layers, and in each layer we do have n number of neurons. Okay, and with the help of those neurons, I may be able to understand, or my model will be able to understand, the hidden representations that exist inside the data. So next, let us move to next term, that is parameter, which is nothing but weights. Let us take an example. I want my model to predict whether a particular person will buy a product or not. Okay, so again, based on some past purchases, based on some past experience, I can feed the model. Okay, why I say past experience? Because I need to predict if a new product has been launched in the market, then I need to, this is user specific problem, correct? So in user specific problem, what we need to do is, I cannot give the generic predictions. What we mean by generic predictions? Generic predictions are nothing but the example that I have taken in the last session, that is customers who have bought this, who have also bought this item. But here this is not a generic prediction. Try to understand this. The prediction is user specific prediction. Okay, predicting whether a person will buy a product or not based on the past experience of that user only. Fine. So I may be having some input data. Fine. And in this particular input data, for simplicity, I can take n number of data. Okay, but for simplicity, I have taken some values, the x1, x2, x3, x4, and x5. Here, x1, x2, x3, x4, and x5 are nothing but attributes, not data. These are attributes of a particular person. Okay, let us say x1. Fine. X1 as an age, x2 as person's, you can say person's salary. Okay, x3 is giving the value, or the attribute, or it is indicating the attribute whether a particular person has purchased any time, has he purchased any newly launched product, yes or no. Okay, so that attribute also I do consider. The fourth attribute that I'm considering is sale. Okay, so mostly users do attract towards the sale. Fine. Whether this particular person has in the past, has he purchased any items or products uh, which were in sale. Okay, so that attribute, like this, I can enlist n number of attributes. I could have taken some other notation here. Don't confuse these x1, x2 as individual samples. Okay, here x1, x2, x3, x4, x5 are attributes of the same samples of the same person. Fine. So based on the past experience, I want to predict whether a particular person will purchase the product or not. Right. So for this, I have represented the model with simple neuron. In a single neuron, I'm giving all the attribute values Fine. And I'm trying to find out some function. That function can be linear, or that function can be any other function. Okay, it can be linear function, it can be sigmoid function, it can be any function we can think of. But here my question is, based on these, if these attributes are given, then am I able to compute y hat directly? One of you can unmute and answer.
No,
Can
ma'am.
you repeat the question?
Yes, one of you can answer.
Can you repeat the question?
Okay. Here, my question is, based on data items, if I provide you data items, suppose x1, x2, x3, x4, x5 are attribute values of the last purchase. Similarly, like this, I can have different attribute values of the previous purchases of the person. So based only on this data, am I able to, or my model, is it able to produce this y hat?
No, ma'am.
Based only on these attribute data?
No, ma'am.
No. Correct. Why no?
I think you need your y to compare to the model. Yes.
We will get y cap, but it's not necessary that it will be equal to y.
Okay, okay, right. Yes, definitely. As
So I
you
think
have
we can
answered it
calculate.
correctly. Yes, please mute yourself. I got the answer. So definitely based only on these past attributes, I may not be able to get y hat, correct? So what I need to do is I need to provide some weights with each of these attributes. Maybe I am more interested in providing more weightage on X1 because X1 was indicating age of a person. Similarly, X2 was indicating salary of a person. Suppose if a particular person is earning very less, then I can't expect that a person will purchase newly launched product every time, right? So probability of purchasing a person whose salary is very low will be low. Fine. Whereas age and this attribute, that is X2 attribute, salary, I would like to give high weights compared to other attributes. Okay. So here parameters that are weight learning is very, very important. Fine. So what is that exact weight? What will be that exact weight? That those weights should be learned by the model. Okay, learned by the model. So I say whenever there is a minor change in the weight, there will be huge difference in the y hat and y. Fine. So how do I learn the weight then? Again, there are many weight learning algorithms. Where those learning algorithms, what they will be doing is they will be giving you, or they will be giving us the easiest way to compute weights, or to compute the weights of a model, so that whenever I feed X, it should provide me correct value of y hat. Okay, so this is nothing but weight learning. Now, initialize, how do I start with then? Because these weights are actually unknown to us. I don't know what weight value should be given to X1, what weight value should be given to X2, X3, X4, and so on. So that whenever if we feed this data items, attribute values, and these weights, with these along these weights, my y hat will be equal to y or closer to y. Fine. So in subsequent lectures, we will see how do we make or how do we learn the parameters, or how my model will learn the parameters? We will see in the subsequent lectures. Okay, so this figure just illustrates that each corresponding attribute will have some weights. So now learning is nothing but finding the values to all the weights here W1 to W5, so that the function should give correct predictions. That means loss should be equals to 0 or very, very negligible. I can bear with some loss, but that loss should not be high. Okay, I can bear with minimum loss. Minimum loss is okay with me. If my model is not giving the loss as 0, if it is giving the loss error rate as 0.0001, then I can bear with that particular value. But here actually what we say is, we do say that my model is learning, but what it is actually doing, it is trying to find out the values of these weights for the corresponding attributes, so that it should provide us the predicted values, and these predicted values should be closer to the y. Okay, now can we assign weights manually? I have written already, but you may answer, can we assign these weights manually?
No, we can't.
No, since they are just values, we can assign them, but it won't make sense to assign it manually.
Yeah. Then
Yes,
there will be nothing to compute actually.
yes. Please mute yourself. Very much correct. We cannot assign the weight manually because there are situation here. There are only 5 attributes. So with ease guess, I can approximately, I will start with some initializing some with some random values W1 to W5, and I can change W1 value, W2 up to W5 values with some values. Okay. And I will try to check whether my approximated weights are giving the correct values or not, whether this y hat is going towards y or not, or reached y or not. But the problem will come when we have millions of parameters. Okay, leave about millions of parameters. If my data has thousands of parameters or hundreds of parameters also, this learning or hand coding these weights will be very, very tough for us. Okay, so we cannot compute it manually. So for that sake only, we do say that we need to write an algorithm such that that algorithm should find out these weights automatically whenever we do provide the data items. Definitely from data items, from samples only, my model will be learning the weights. Okay, that is true. Let us take the next term as loss function, or many authors, they do refer it as an objective function. We have discussed about loss function, but not the key term as loss function. Again, I do provide input X and corresponding weights I will provide to my layers or a network of neurons, and later on my network of neuron or my model will give me the predicted result, that is y hat, and with my corresponding input X comma Y, I do have my ground truth. And what my loss function will do, my loss function will compute the loss between y hat and y. Okay, it actually computes the score between this predicted value and the actual value. Fine. So what is the functionality of loss function? It is simply helping me to judge whether we have or my model has reached whether this is closer to this or not. So when I will get higher score here, again one of you unmute and let me know.
When the difference will be very low.
Okay, good. Please mute. Whenever the difference is very low or equals to 0, then I can say that my predicted value is same as my actual value. Okay, so the score itself will indicate whether y hat is closer or near to y or not. If my predicted y hat is very far off from my y, then the score will be very high. Okay, so what shall I do if my score is very far off from my actual y? Then I need to again retrain for the same example, right? So here this slide indicates how do I compute the loss given y hat or given predicted y hat. Let us take some example or standard loss function that many authors they do use. Sum of squared error loss. Okay, so here is the ground truth y, and for 5 different items, data items, right? Here is the predicted y hat. Fine. So now, how this sum of squared, what is the formula of sum of squared error loss? You all might have used this multiple times, but this loss function again we will be using it to compute the score, loss score, right? So it is nothing but summation of yi minus y hat of I whole square. Okay, so ground truth value is 1. The first row is indicating the ground truth value of first item, and this is indicating the predicted value of the first data item. Similarly, this is actual value or ground truth value of the second data item, and this is predicted value of the second data item, and so on. Correct? Now we can easily when we see these two table values, we can roughly tell whether we have reached zero loss or not. Correct? So but still there should be some measure. Based on that measure, I can easily evaluate and easily tell that yes, I have not reached to the minimum loss or zero loss. Fine. So how do I compute? I will compute the loss function with this particular formula, that is actual is 1 whereas the predicted is 2. So 1 minus 2 whole square plus the second one, second data item 2 minus 3 whole square, 3 minus 4, 4 minus 4 and 5 minus 4. Take summation of all these and it will come out to be come the output as 4. Fine. So now there are different loss functions which are available. One is mean squared error. Just now we have seen some squared error. When I take the mean, when I take the mean in this, if I take, if I take mean of this loss, then it comes out to be we can say it as a mean squared error loss. Okay, and here you can see for the previous formula only we have just added this term, that is 1 upon n. Similarly, mean absolute error. In mean absolute error, instead of squaring this yi minus yi hat, I do take absolute of yi minus yi hat. Correct? Now, let us take the next one, that is loss function. Fine. You might ask why we haven't used simple yi minus yi hat. Why we have used the sum of squared error loss or mean squared error loss? Because whenever I do sum of error loss, if I do that, let us take an example. My ground truth is for only 2 items. I have taken this example. I have computed this. Okay. My ground truth of first item is 1. Ground truth of second item is 2. Whereas my predicted value for the first item is 2, and for the first one, for the second one is 1. Fine. Again, based on this particular formula, without taking square, you can notice the problem here. Even though there exists an error, whenever I wanted 1, it actually, my model has actually predicted 2. Whereas whenever the ground truth is 2, my model has predicted it as 1. So there exists some error. Fine. But if I use this simple error, okay, that is difference between ground truth and predicted. If I take sum of difference between ground truth and error, then this particular example, it gives the value as 0, right? So what it is doing, it is actually, there is a problem of sign, correct? So 1 minus 2 comes out to be -1, 2 minus 1 comes out to be 1. So -1 and +1 get cancelled and it comes out to be 0. But here there exists an error, one error over for the first one and one error for the second one. So when I take sum of squared error, then taking this particular squared error square value to yi minus yi hat ensures that the sign of the difference is ignored. Okay, so that sign, this -1 and +1, the sign will be ignored and simply we do try to compute it. Fine. So for that sake only, we do prefer to use sum of squared error loss. And many authors, they do use absolute error. Even we do have root mean squared error. Okay, there are many loss functions. But the most often used loss function is sum of squared error. Let us try to understand the next one, the next term, that is optimizer. Here you can see from the figure, almost it is same as the previous one. That is given input x, given weights, to my model or network of neurons, it generates some predicted value, and my loss function takes y hat and y and it tries to generate some score. And if that score is very high, okay, so what I should do, there is some typing mistake here. It should be optimizer. Okay, I will correct it and I will send it to you people. Here you can note down, instead of loss function, it should be optimizer function. Fine. If the score is very high, then I will provide that score to the optimizer, and with the help of some algorithm, again some back propagation algorithm, we do say as back propagation algorithm. So with the help of those algorithms, what it will do, it will feed it to weights. Okay, it's not weights, actually it feeds the algorithm will be again retrained based on the back propagation algorithm and to my model. Okay, what it actually will in turn do, it actually try to adjust the weights. Fine. With the initial weights, it has given some error. So what I need to do is, I need, with the help of optimizer or with the help of some back propagation algorithm, we need to adjust the weights so that the loss score of previous step should be less than loss score of the current step. Similarly, loss score of the current step should be less than the loss score of the next step. Right? So in every subsequent iteration, my loss score should decrease. Fine. So whose responsibility is that? It is the responsibility of the back propagation algorithm to adjust the weights. Once we try to adjust the weights such that the loss of the current should be less than the loss of the previous one. Similarly, the loss of the next step should be less than the loss of the current step. Fine. That is the functionality of the optimizer. Again, we will see the standard optimizer that has been followed in deep learning in the subsequent classes. But I hope you try to understand by this time. With some random weights, it was giving a score, very high score, because the high score is the loss score is very high. So what we need to do is, again, we need to tune the models, or we need to adjust the model such that the loss of the next step should be less than the loss of the previous step. Fine. Again, you can note here, loss score is very, very important because it acts as a feedback to the signal to update the weights in order to improve the model performance. Correct? Every time in each iteration, we are doing only one process. Okay, only one function. That is, we need to readjust the weights again and again till we get the least loss score. Let us try to understand the next term, that is evaluation, model evaluation. Okay, now we do have, suppose, let us come back to this. Suppose I have trained the model with my input, and somehow with back propagation at each step, my back propagation algorithm has adjusted the weight such that the score that I'm getting is very less. Okay, so that means my model has learned the correct weights now. Okay, with each input you provide, it will generate the predicted output. Output should be, the predicted output should be either equal to y or very, very close to y. That means my loss score is least in that case. So once we achieve that, okay, once we have achieved the loss score as 0 or minimum or equal to or nearer to 0, after doing this, okay, we can say that my model has learned the parameters, which are weights, such that if you feed the test data, new test data, then it will give me the correct result. That means it gives the predicted result, but the predicted result will be very, very close to the actual result. Fine. So once we have completed this whole process in the slide, we need to feed the model with the test data set. And that test data set is such that that test data has not been fed previously while during the training period, right? After we do feed the model with new data or new test data, it will give us the result. It will give its own predictions, correct? So once we get those predictions, then we should be able to tell whether my model has correctly given the result or not. Again, in the test data also, I do have associated every xi with yi. So whatever my yi hat has generated, whatever my model has generated, that it predicted value, I will compare that predicted value with the test data yi. Fine. And for that, for doing this process also, we do have some evaluation parameters, model evaluation parameters. Let us try to understand what are those. Let us consider this performance measurements for ML or DL problems. The same set of performance measurements can be used for ML as well, machine learning as well. So here is the confusion matrix for binary classification. By this time, you all are very much well aware of the term binary classification. I will repeat, those who are not there in the previous session, I will repeat once for you. What is binary classification? Suppose if I want to classify into two classes, okay, if I want to classify any real problem into two classes. Okay, for example, whether the image belongs to whether image comprises of girl or not. Okay, or whether image comprises or consists or it belongs to a girl or boy, right? So that example belongs to binary classification. Multi-class classification, we have also seen examples of multi-class classification. Instead of like classifying only girl or boy, we can classify different fruits. Okay, so for example, I am interested to classify into the whole problem into three classes, right? Whether the given image belongs has apple in it, whether it has banana in it, or whether it has orange in it. Okay, so for this particular problem, what I can do, I need to give the input as while training. I will provide, because I want my model to learn how banana looks like, how apple looks like, how orange looks like. So for that sake, I need to provide different categories of bananas, different categories of apples, and different categories of oranges. Okay, once we feed, while training, once we feed all these different set of images of banana, apple, and oranges, and if I capture the new image and if I feed that particular image in my model, and if I'm while testing, if I'm providing bananas image, then it should be able to generate the label as banana. The image comprises of banana, whether the image comprises of apple, and so on. Okay, that example belongs to multi-class classification. Okay, so here confusion matrix can be drawn for binary classification or multi-class classification as well. But for simplicity, I've taken the confusion matrix for binary classification. Here, this is indicating actual values, that is capital Y. Okay, here these rows are indicating what? The row are indicating yi hat, that is predicted one, predicted by the model, whereas this is indicating ground truth, which we know already, right? So here we do have some terms. The first term is known as true positive. Okay, this cell is nothing but true positive. Before that, try to understand this is positive, which is indicated by 1, class 1. This is negative, which is indicated by class 0. Similarly, my predicted P has 1, class 1. My predicted N, negative class, has class 0. Why I have taken positive and negative should be clear to you by this time, because it is a binary classification problem that we are considering. Correct? So because we are considering binary classification, so I have two classes, positive and negative with respect to actual, and positive and negative with respect to predicted. So now let us try to understand true positive, true negative, false positive, and false negative. Let us try to understand these terms. Okay, true positive means your model has predicted positive and it is true. Sorry. Whereas true negative is nothing but your model has predicted it as negative and actually that is also true. Fine. See, you can check with this matrix itself. TP is indicating actual mean what it is in actual, it is positive. Even my predicted positive is showing as positive. Actual is also positive. Predicted is also positive. Hence, it is true positive. Whereas true negative is actual is negative. Whereas predicted is also negative. Hence, it is true negative. Fine. let us try to understand what is false positive then. Your model has predicted positive and it is false. That means your model, that means it is falsely being predicted as positive. Fine. So that is nothing but FP. Fine. So even many authors, they do refer it as a type 1 error. Fine. Actually, it is negative. This class could have been belong to negative class, but my model has given it as positive class. Hence, it is known as falsely being positive or false positive. Similarly, the last term, that is false negative. False negative. That means actually the class is should belong to positive. Actually, the class, this could have been added over here because it comes under positive, but my model has done negative, right? So your model predicted negative and it is false, falsely being negated. Fine. So these four terms are very, very important because based on these four terms only, we are going to compute evaluation of the model, that is accuracy. Fine. So one must understand, given matrix, given confusion matrix, then one must be able to understand what is true positive, what is true negative, what is false positive, and what is false negative. Okay. Let us try to understand with the help of some examples. Suppose a user has taken the COVID-19 test and we say, when the test says you don't have it, that means the test report. Okay, here the test report gives you don't have it, but you actually have it. Fine, which is more dangerous, right? So we do say it as a false negative because it is, my test report is saying that you don't have the COVID-19. But actually, I do have all the symptoms and I am suffering from COVID-19. So hence it is false negative. What is false positive then? When the test reports gives you, yes, you have it, but actually you don't have it. This is nothing but false positive. Again, this is also problematic because without having a COVID-19, you may be given some like medicines, right? So for that sake, even false positive is also not good. False negative is also not good, right? Whereas true positive and true negatives are like whatever we do expect from the model. Fine. When the test says or test report says you don't have it and you actually don't have it, so the term we say it as in true negative. Similarly, I can have the other category as true positive, which is when the test says you have it and actually you have it. Okay, that is nothing but true positive, right? Let us take one example as forest fire detection system. Okay, let us try to understand with this particular example also those four terms, four different terms. If the alarm goes on, so whenever there is a fire in the forest, then there should be some, there should generate some kind of alarm system for the, it should generate some alarm system so that necessary action can be taken, right? If the alarm goes on in case of a fire, it is true positive, right? There exists, the fire is there and my model has detected or the system has detected that there exists a fire, right? So, and it has generated the alarm. For that sake, it is true positive. If the alarm goes on and there is no fire, then the system predicted fire to be positive. But it made a wrong prediction. Hence, prediction is false. That is false positive. In a similar way, if alarm does not go on, but there was actually a fire, right? The system predicted fire to be negative, which was actually false, correct? So since there was a fire, fine. The last section, finally, if alarm does not go on and there was no fire at all, the prediction was true, right? There was no fire and there is no alarm being generated. Hence, it is again a true. That is true negative. Fine. Let us try to understand the next term, that is accuracy. So how do we say, how do we compute the performance, or how do we evaluate the performance of the model? The performance of the model is evaluated based on the accuracy of the model that it generates. For example, based on this formula, we do compute the accuracy of the model. So accuracy of the model is computed based on true positive plus true negative upon all four: true positive, true negative, false positive, and false negative. Okay. So again, instead of COVID-19 here, we do have some data as true positive and true negative for dengue fever test. Okay. True positive value is 0, whereas true negative value is 270, false positive is 0, and false negative are 30. Okay. So in that case, if we need to compute the accuracy of the model, so accuracy of the model can be computed with this particular formula, that is true positive plus true negative divided by all these terms, 4 terms. It comes out to be 270 divided by 300. It comes out to be 0.9, that is 90%. Fine. The next one is again the parameter or the evaluation metric we can see, and evaluation metric, that is error rate, can be computed with the help of this formula, that is false positive plus false negative upon true positive, true negative, false positive, and false negative. Okay. Or else, once we have computed accuracy, then we can simply say that 1 minus whatever model accuracy that it has generated. This error rate is nothing but the percentage of misclassification, right? So for the same example, we can say we can compute the error rate. Fine. So error rate based on the formula only, fp plus fn, that is 30 plus 0 divided by all these 4 terms. Okay, divided by 300. It comes out to be 0.1. That is 10% error exists in the model. We can see like this. The next term, we do have 2 more terms. The recall is nothing but it is out of all positive classes, how much we have predicted it correctly. Okay, that gives you recall. Recall, most authors, they do also call it as a sensitivity or true positive rate. So how do I compute the recall? The recall can be computed based on this formula, that is true positive divided by true positive plus false negative. That is this value divided by summation of this. Fine. Precision. So again, precision, how do I compute the precision of the model? Precision of the model can be computed with true positive divided by true positive plus false positive. That is this. Okay, that means out of all positive classes we have predicted correctly, how many are actually positive? Fine. The first row is indicating the predicted value, that is as true. Fine. Whatever values that my model has predicted. So these values my model has predicted as positive. Okay, but actually these are falsely being made as positive. It could have been negated. Fine. So how do I compute the precision in that case? Precision can be computed true positive divided by true positive plus false positives. Okay. Now we do at the end, we can always compute the score, that is F1 score. F1 score is computed based on the harmonic mean of precision and recall. That is 2 multiplied by precision into recall divided by precision plus recall. So these are the different evaluation metrics which are available: accuracy, error rate, recall, precision, F1 score. Fine. Based on these different evaluation metrics, we can evaluate the performance of the metric. Right? These are the different references that I have used for today's session. Fine. Sakshi?
Yes, ma'am.
Okay. I'm done with today's session. I do have some problem. I can share that problem with the students, right? You can share the problem
Yes,
with
ma'am.
the students. I will be
Okay.
sending you. So let them
Yes.
solve. Fine. If there
Okay,
is
ma'am.
any,
We'll make assignments for the same.
yeah, we can.
Okay.
We can. Right. I do have some problems ready, but right now I have listed one problem. I thought I will give it as an home assignment to them. So let them work on it and let them solve it. If you want me to provide it as an assignment, we can always provide.
As you wish, we can, if it is for one, we can provide them as home assignment just for the day. And if we have more number, we can make that as an assignment. Or as you
Okay.
say.
Let me complete few more sessions and later on we can give the assignment.
Okay, ma'am.
As of
Sure.
now, I do have one problem. I will share with you by the end of day so that you can share the same problem with the students, right?
Okay, ma'am. Thank you.
Welcome. With this, I will stop my session. If any kind of queries are there, then you're most welcome to ask.
So anyone having any query?
Hello.
Yes.
Yeah, I have one query. Why this matrix is known as confusion matrix, and what is the purpose of this confusion matrix in the deep learning?
Okay. Actually, the confusion matrix is not at all a confusion because we do have systematic way of representing. I don't know why they do have given the name as confusion matrix. Otherwise, you yourself can see it. It is very systematically been understood because every rows are indicating either those rows and columns I can always interchange. Columns I can make it as predicted and rows I can make it as actual. That is not an issue. Otherwise, it is very much clearly understood by each and everyone, right? And what is the role here is definitely how do I evaluate your marks, or by the end of the day, after going through the semester, how do your teacher evaluate you people, right? By definitely taking some test, correct? So before that, let me take one example. Okay. Let us take some computer programming course. In that computer programming course, I do make my students to understand what is problem. Okay. How do I solve the problem? Problem can be, first we need to understand the problem in detail, like etc., etc., right? So after understanding the problem, how do I solve that particular problem? The problem can be understood or solved using different algorithms, different ways. One way is algorithm. With the help of algorithm, I can solve the problem stepwise. I can systematically solve it, or else with the help of flow chart also I can solve the problem. Okay, so let us take that your teacher has given you in the class, in subsequent classes or in set of classes, he or she has made you to understand how do I write the algorithm to compute sum of two numbers. Okay, or how do I compute the difference of two numbers, or let us take how do I compute the largest of three numbers. So let us take these, with these three example, what you have done, you have understood the actual how do I solve the problem with the help of either with the help of algorithm or with the help of flowchart. Okay, so once we have understood how do I solve the algorithm, or sorry, how do I solve the problem with the help of algorithm, I do given any problem I can solve it. Correct? For example, with the help of like you can say with those three example that teacher has made me to understand in the class. Okay, so I have understood how to solve the problems, those three problems. That is nothing but training data, training period. Okay, training period of a student, because teacher is given a proper training. Okay, teacher is providing a proper training to a student, so where student is learning, right? And later on after that, after student or teacher intends to evaluate a student, whether how do student perform if I give him or her a new problem. So in that case, suppose swapping two numbers has not been covered in the class. Okay, but you yourself know how to solve swapping of two numbers, right? So what you can do is you will apply the same procedure, right? Only change is that first step is start, second step is take two input values, two input variables where you want to swap to. So the first few steps and last few steps will remain, print the result, last few steps will remain same. The only logic here is intermediate step, I can say. There we used to do c is equals to a plus b, but here I need to write three different three different statements. C is equals to a equals to b and b equals to c and so on, if I'm swapping two variables with the help of the third variable. Okay, so in that particular case what I'm doing, I'm what you people are doing, you people are actually or your teacher is actually evaluating you by giving you new test, fine, new test data. That swapping two numbers is nothing but new test data. Now let us come back. By this time you know what is training and what is testing, right? Training is nothing but you are being trained on a particular set of problems to solve, whereas if any new problem comes arrives in front of you, you should be able to definitely approach the same procedure, but you will able to solve it. That is nothing but testing. Now how your teacher will be evaluating, though you have written the answer and submitted it, but your teacher has some approach to evaluate. They will a teacher, he or she will evaluate each answer sheet of us of from each individual, and they will come to know that who has solved it correctly and who has not solved. Okay, by giving some marks, right? In a similar way, how my model has will perform, okay, how it will generate the result. So that need to be done with the help of some evaluation metrics, which are nothing but I've listed so many, but very important and most widely used is accuracy. Fine. Is that clear? Yes, Sakshi, you may continue.
Is there anyone having any other doubt? I think, ma'am, there are no more doubts. We can end the session for a day. Thank you so
Okay.
much for this lecture, ma'am.
Thank you so much, Sakshi.
I
I
have
will be leaving now.
Okay, ma'am. Thank you.
I have a
So I
question.
have pasted the attendance link.
Hello?
Someone was saying something?
Yes. Can you hear me?
Yes, sure.
It's next Thursday. We don't have lectures.
Next Thursday.
Yeah, I've seen the calendar, and Thursday is missing. So I'm asking if on Thursdays are we having
No,
a lesson?
we have lectures from Monday to Friday.
Okay.
You will be
Okay,
having lectures on Thursday as well. It is from Monday to Friday.
okay. Great. Thank you.
Okay.
Ma'am,
So for the column as roll number that is there to be filled in your form for attendance, you need to write your particular roll number that we have provided in the mail given to you. If you haven't received any mail regarding your roll numbers, just type in the chat window.
ma'am, where
You
you
told
have
you
provided
will upload
the
in.
form?
One by one, I couldn't understand any one of you. Any one of you, please speak first. I think Vamsi was speaking something. You speak first, and then the other one.
Yes, ma'am. You told yesterday that you will upload the Excel sheet in WhatsApp group. It will be better if you send the Excel sheet in WhatsApp group.
Okay, I'll upload it. Don't worry, I'll upload it today.
Okay, ma'am.
Ma'am, what about the classroom? Google Classroom?
So we'll make that as soon as we make the assignments. Because ma'am said that we need 2 or 3 questions for the assignment. Just we are waiting for the assignment and we'll make the WhatsApp. The classroom with that only. So that
Okay,
you'll have something to submit in the classroom. That's why we are
okay,
waiting for the assignment.
okay.
Anybody else having any other doubt?
No, ma'am. Thank you.
So thank you everyone. I think we are good to end the session now.
Thank you.
Thank you.
Everyone.
Thank you.